Hello and welcome to SudoKanard. We're here to solve this Between Sudoku by Indian author James Peter that was featured in the latest round, the first round of 2023 of WPF Sudoku Grand Prix. It was the highest pointer puzzle in the whole set, and it was definitely the most difficult. It actually included a couple of really difficult steps. And apart from that, it flowed quite naturally. I didn't solve it during the contest because I was afraid of it, to be honest. But I solved it afterwards, and there was quite some struggle. So I tried to find what the point was. So the rule first. So whenever you have two circles linked by a line, it means that all digits on a line must lie strictly between the numbers on the end. For example, if this is a 3 and this is a 6, so no, 6 is not allowed, let's say 7, then all those digits must be from 4, 5, 6. And of course, this won't be a 6, this can only be a 5, that's not a 5, but that's an example. This is not necessarily the values that we put into those cells. So that's it, and the rest is standard Sudoku. So a natural place to start here is to have a look at the nines, because something that follows immediately from the special rule is that on those cells you can never have a 1 or a 9. So that's a real restriction, because 9 can't be here and 9 can't be on those cells. So 9 must be here. And let's see if we can do more. 9 can't be here, it can't be on those lines, so 9 must be here. And obviously the same happens here. So we have a 9 somewhere here. And this prevents all of those cells from containing a 9. So 9 can't be here either. It can't be here. So here we're left with 3 places for 9. In this area, 9 can't be here because of this. It can't be here. So we have a 9 somewhere in here, and it eliminates those options. So we get a real 9 in this cell. Now with this 9 and this 9, we get a 9 somewhere here, but it can't be on the line, so 9 is here. So no 9 here, no 9 there, no 9 there, and no 9 there because of this. So that's the 9, that's the 9. So we are left with just this ambiguity. And now let's see if we can do the same with digit 1. Well, those 9s were strategically placed, obviously, but it's not the same with 1s. Well, 1 is not in here, 1 is not in there. So still 3 options for 1 here. So 1 is not here, it's not here, it's not here. So there's a 1 in 2 positions there. And 3 positions there. Well, I just pencil mark them just because why not? So this one may be interesting. There's no 1 in here, so there's a 1 somewhere there. Because of that, no 1 here. Because of this, no 1 here. It can't be on this line, so there's a 1 somewhere here, and it eliminates this. Let's hope that's interesting. What about this region? So at this point we know that 1 is not here, it's not there. Could be in any of those 4 cells, apparently. Or perhaps I should focus on the middle region, because 1 can't be in any of those, and because of this it can't be here. So 1 must be in one of those 2 cells, so we can eliminate this and put the 1 there. And then it eliminates this option because well, once we can't have the same digits on both circles on the between line. So now on this column, we know because of this that one is nowhere here. It must be here, but because of this, it's not here. And it's not here because of this one. So that's the one. Beautiful. And we get this one as well. But those and those can't seem to be disambiguated right now. So what do we see? So what restrictions do we have with those? Because of this two, this must be at least 3. So this must be at least 4. But because of this, it's at least 5, and it's none of those. So this is 5, 6, or 8. Here we also have restrictions because of those 2's. Here we know that 2 is not here. So the minimum values for those cells are 3 and 5. So this is at least 6, but it's none of those. So this is 7 or 8. And actually, this 8 is interesting because we know that 8 can't be here because this is not 9. So 8 must be somewhere here. But 8 here wouldn't work. It would require this to be a 9. So 8 has only 2 options here. Well, this could be basically anything, or perhaps not. 8 is not available, so the maximum values here are 6 and 7, so this has a maximum of 5. And with those restrictions, it's 1, 3, or 5. We see that those ends, those circles, they don't contain a 9 nor a 1. So that's interesting because of that, 2 and 8 can't appear anywhere on the lines because a 2 needs a 1 somewhere on the end and 8 needs a 9 somewhere on the end. And so 8 can't be here, and because of this 8, we know that 8 must appear in one of those 2 cells, so this is a 1-8 pair. And now there's an 8 somewhere here. And an 8 here seems to be very restricted with that. Oh, I remember, that was the tricky step. That was the real tricky step in solving this puzzle, was noticing that 8 here would put a lot of pressure here, and we can see where. All right, let's try to put an 8 here. Then those digits here must lie between 8 and this digit here. But look, because of this 6 and this 7, this can't be bigger than 5. But if this is 5 or less, then there's no option for this, and this is why 8 here doesn't work. So 8 is here. And I think I remember that the puzzle was almost crumbling at this point, almost collapsing, but perhaps I had put more thought into the puzzle, and I've been biased by this memory of this very step. Look at those 8. So 8 must be here, but it won't be on the line because 9 is not available for the ends. So 8 is on this end, and it puts the 1 here, it puts the 1 there. So, well, now this between 9 is really not restricted. Because this 2 is not here, it can't be on the line either, it must be there. And there must be a 2 somewhere here, and that's interesting because this is not a 1, this is not a 1, this is not a 1, so 2 can't be on the line, so 2 can only be here. And 2 can't be here for the same reason. That's not a 1. So that's a 2. And that's a 2 by Sudoku. So now 2 is nowhere here, and we already knew that, so there's a 2 somewhere here. There must be a 2 somewhere here, but there's a 2 there, so that's a 2, which is perfectly legitimate on this line with a 1 here. And then we must have a 2 somewhere here. It can still be on the line. Oh, but with this, we know 2 must appear somewhere there. So that's not a 2, and that's a 2. But 2 here would require one of them to be a 1, which is not the case. So we have all 2s here, and this is not restricted at all. It can be a 3, it can be anywhere, any digit from those still available on this row. And this 2 removes this option, so that's a 2. So at least 3 and 4. This is at least 5. So it has to be 5 or 6. Here we have at most 7 and 6. So this is at most 5. So it can be 3, 4, or 5 at this point. Now, what are the options here? The remaining digits are, well, let's just say 3, 5, 6, 7. But 7 is not here. 7 can't be here. Well, the maximum values here are 6 and 7, so this is at most 5. But 5 is not available, so that's a 3. And this is finally a 6. Up there we get a 4 and a 7. Here we need 3, 5, and 6. I see no more. Oh, that's not a 6. So there was a 6 somewhere, but it's not saying much because 1 and 9 are not restricted at all. There must be a 4 somewhere in here. Oh, this 6 is interesting because this can't be a 6 anymore. And if I try to put a 5 here, that doesn't work. If I try to put a 5 here, then because of this 6, this must be bigger than 6, but 8 and 9 are not available. And if I try to put a 7, then all of those must be 6s, and this breaks because of that. So this is 8. And now, so this leaves a lot of options for those cells. But what about this region? Oh, actually 8 is here just by Sudoku. So that's the 7, that's the 8. 3, 5, and 6 here. So those are the unrestricted digits. They go anywhere. Interesting point here. We get a 3, 5, 6 triple. So this is a 4, 7 triple. And those digits are the same. Perhaps I can find which ones. Yes, 7 wouldn't work because if those are 7s, then one of those ends must be bigger than 7. But we see that with those digits, none of those can be an 8 or a 9. So this can only be a 4, and that's a 7. That's not 4. So now one of them must be bigger than 4, and the other must be smaller than 4. So this could be so one of them has to be a 3. And I don't think I can find which one. This 3 would be very nice because of those 2s. But it can still be this one. So well, let's look elsewhere. So those must be 3, 4, and 5. That's not 4. Those are 6 and 7. There's a 7 here, so that's the 6 and that's the 7. So it puts no pressure on this digit, but this 6 makes this a 5. That's a 3, and that's a 4. So we get some eliminations there. Well, this 7 disambiguates the 5-7 pair, so this 5 makes this a 3, this is 6, this is a 5, 6 and 5 here, 3 and 5 here. That's a 4 and a 6. And here 9 and 3. Here that's 3, 7 and 8. This is not 8. This is not 7. Here I need a 4 and a 7. That's the 4, that's the 7 because of this. Here we get 3 identical digits again. What about those 3 digits? There must be 3, 6, and 9. So this is 3 over 6. So they could, one of them has to be a 3 and the other is the 6 or 7. So nothing definitive here. Here I need a 6, but there's a 6 here. So that's the 1, that's the 6. So that's the 8, that's the 1. That's not 8. Oh, so that is a 5, by the way. That's 8. So those must be between 5 and 8, so they must be 6 and 7. So that's 3, that's 7. Oh, I'm so disappointed. 3 would have made so much more sense, but that's it. So that's a 3, 4 and 6 here, but well, because of the between and because of this 6, that has to be the 4. 3 here, so that's not 3. 3 is here, and 9 goes there, and that's the 6, I think. Here I need the 3 because of the between line, and the 5 here. And let's finish with a 3 there, which definitely lies between 1 and 8. Here that's a 5, and it lies between 3 and 8, and that's the 4, and this is correct. So a truly tricky, challenging puzzle, and it was the highest point, I think, in this round, but it was still a really fair puzzle. There was nothing completely outwardly in the logic. There was just this difficult step with noticing that those could only be 5, 6, or 8, which prevented this from being an 8. That was, I think, really the difficult breaking in the puzzle, and that there was still some work to do, but really everything just fell into place. So a magnificent puzzle by James Peter, as usual. Thanks for watching this video. See you soon on SudoKanard for other online contests, solves, all things like that. Perhaps the German Championship qualifier or the Sudoku Mahabharat.